Algebra 2, Chapter 9, Section 1. In this lesson, we're going to discuss the inverse variations and combined variations. We're going to learn how to use them, both inverse and combined. So let's get started. All right, in chapter study, we learned about the k-value, or direct variation. A direct variation is a linear function in the form of y equals kx, where k is a non-zero constant of variation, and the function in the form of y equals k over x, or k times y, or sorry, x times y equals k, where k is not zero, is considered an inverse variation. So notice the difference, okay? So the table and graph show below the time needed to bike 24 miles pedaling at different rates. So at 3 miles an hour, it takes them 8 hours. At 6 miles an hour, it takes 4. At 12 miles an hour, it takes 2. And at 24 miles an hour, it takes 1. Notice as the rate increases, the time decreases. Doubling the rate halves the time. So the inverse variation of this is t, which is time, equals 24 over r, 24 over the rate. What else do you notice really quickly is the rate times times always equals 24. Okay, so think about this real quick. Time is in y, it's on our y-axis. The rate was x, so x times y equals our k value. Our k value is 24, so we could say x times y equals 24, or y equals 24 over x. Okay, so let's model an inverse variation. Suppose that x and y varies inversely, and x equals 3 and y equals -5. So you see vary inversely. So you could say y equals k over x, or you could really say x times y equals k. What's my x value? 3. What's my y value? -5. So what's my k value? -15. So I could rewrite it as y equals -15 over x. So we're going to go back to that look. Okay. Suppose that x and y vary inversely. So that tells you again inversely. So you can remember this. Y equals k over x, or you could just say x times y equals k. It gives me an x value of 0.3. Gives me a y value of 1.4. So that's going to equal k. So 0.3 times 1.4 is 0.42. So that is our k value. Go back to the initial one, since it varies inversely, so we can now say y equals, what's our k value? 0.42 over k. Answer is B. Pretty simple thus far. All right, identify direct and inverse variations, okay? Let's talk about this. Is the relationship between variables in each table a direct variation? That means this, y equals k times x. An inverse variation, that means y times k equals x, or you could think of it as y equals k over x, or neither. Write a function to model the direct and inverse variations if it exists. So if y equals k times x, then what we can say is the y over k value is always going to be equal to the other points. If the inverse is going to be equal, we know, and this is what I mean by the inverse, we know y times x is always going to be constant. So let's see. So first we can just divide them. So 0.5 goes into 1.5 3 times, 2 goes into 6 3 times, 6 goes into 18 3 times. Well, since they divide into each other equally every time, that's a direct variation of 3. So we could say y equals 3x. Okay, so let's divide these. 0.6 goes into 12, or 0.2 goes into 12. That's a lot of times. 5 times 12, 60. So 0.6 goes into 4. Well, not 60, so it's not a direct variation. Let's now multiply them. 0.2 times 12 is 2.4. 4 times 0.6 is 2.4. 1.2 times 2 is 2.4. So this, since we multiply them together, we can say x times y always equals 24, or 2.4 I should say. So y is equal to 2.4 over x. So that's an inverse. The last one, multiply them, or let's divide. 1 goes into 2, 1/2. 2 goes into 1. Actually, 1 goes into 2. I lied, 2 times. 2 goes into 1, 1/2. Okay, so direct variation is no good. So let's try inverse variation. 1 times 2 is 2. We're looking good. 2 times 1 is 2. We're looking good. 3 times 0.5 is 1.5. So it is not an inverse variation. So it is neither. Make sure you understand that. If x and y multiply together and it gives you a constant, it's the same number every time, it's an inverse relationship. If x over y or y over x is the same number every time, it's a direct variation. And if neither work, it's not a variation at all. Okay, is the relationship between the values in the table direct variation or inverse variation or neither? So, let's look. I can multiply them real quick. 0.8 times 0.9 is 0.72. 0.6 times 1.2 is 7.2. So it's not an inverse relationship. All right. What about direct variation? They divide evenly in each other. 0.8, or make fractions, is not equal to 0.6 over 1.2. So it is not that either. So it is neither. 2b, is a relationship direct variation or inverse? So direct variation means x over y is going to equal x over to y. So let's look. So do I have 2 over 3.2? Is that equal to 4 over 1.6? No, it is not. You can cross multiply if you need to prove it. So that means it is not an inverse. It's not a direct variation. So it's not that. So what does an indirect or inverse variation mean? Well, that means x times y equals the same thing. So 2 times 3.2 is 6.4. 4 times 1.6 is 6.4. 6 times 1.1 is 6.6. So again, it is neither. Okay, 2c, is the relationship between the values in the table a direct variation, inverse variation, or neither? So let's look. 1.2 goes into 18. I don't know, but we can get our handy dandy calculator out and do that. Okay, so 1.2 divided by 18, 0.0666, okay? 1.4 divided by 21, that looks the same. 1.6 divided by 24, that looks the same. All right, so what must that mean? Okay, well, it must be a direct variation. So y must equal a kx, or an xk. So we'll just plug in. So 18 equals 1.2 times k. So k is going to be 15. So we can rewrite this as y equals 15k. It's a direct variation. Okay, hopefully that makes sense. All right. Heart rates and lifespans of most mammals are inversely related. Use the data to write a function that models inverse variation. All right. So we know if there's an inverse variation, we can say we know heart rate times lifespan is some constant. So RS equals K. When you do the math, RS is close to 1 billion. So 1 billion we sub in for K. So we got RS equals 1 billion. Okay, so it's in beats per minute and lifespan per minute. Okay, so estimate the average lifespan of a cat with a heart rate of 126 beats per minute. So you substitute 126 for R, so S is about 8 million minutes, or a cat's lifespan is about 15 years. All right, a squirrel's heart rate is 190 beats per minute. So we know R times S equals 1 billion. So if the squirrel's heart rate is 190, so its lifespan is 1 billion over 190. So let's do the math. 1 billion, 1, 2, 3, 1, 2, 3, 1, 2, 3, divided by 190. Okay, so that's going to give me minutes of a life, correct? Well, how many minutes in an hour? So divide by 60. How many minutes in a day? Or how many hours in a day? 24. And how many days in a year? 365. So a squirrel's lifespan's about 10 years. Okay. An elephant's lifespan is about 70 years. Estimate its average heart rate. So RS equals 1 billion. All right, well, the lifespan is 70 years. So there's 365 days per year. Years cancel. 24 hours per day. Days cancel. All right, 60 minutes per hour, and the hours cancel. So now we can get S in a form of minutes. So let's do that real quick. So we did 70 years, 365 days in a year, 24 hours in a day, and 60 minutes. So it's going to beat 36 million or whatever. So 1 billion, it's 9 zeros, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 8, 9, 1 billion divided by the answer. 27.17. So the heart rate's about 27 beats per minute. So the R is 27 beats per minute. Okay. Using combined variations, part 2. Okay, we'll stop here for a second. We'll pick up part 2 in the next lesson.